All right, hey, how's it going? So we're at that point. It's near the end of the semester and we have just a little bit more. So this project isn't a full project like the other ones. This is a small project with a few fill in the blank spots and it counts as part of your final. So it shouldn't require as much time as the other projects, but it covers a few concepts we haven't touched so far. So let's jump straight into it. So the first thing that's different is we will be importing some assets. So I'm going to pause right here and create the standard assets folders. All right, that looks much better. So the first thing you'll see is there's a zip file in the project that will have a few files included into it. The first thing we're going to look at is a file called level.fbx. And fbx is just a model format, so we're just going to drag and drop that into our project. And Unity will import that. And then from there we can drag that onto our scene. Let's set the origin to 0, 0, 0, and we have the beginnings of our level. So let's save our scene. The next thing we want to do is add a mesh collider component. So under physics, mesh collider. And this gives our level something physical that we can interact with. Otherwise, once we add our character in, they would just drop through the floor and kind of float off into oblivion. So now that we also have a model in here, let's create a folder called models. And just drag that in there to keep it neat. I'm also going to create a new folder called textures. In that folder, I'm going to drag in our two textures. All right. Now, if we go to our materials folder, we'll see there's already a material here. If we click on our level, we'll see this material is the same one. So this was automatically created. So we want to modify this a little bit. So let's give it a name. Level 1 matte. And under the albedo, we have this little selector. Let's select the wall segment. So that gives a little bit more detail to our level. Then under normal map, let's add this kind of purplish bluish picture. And normal maps are basically ways of simulating geometry and depth without actually adding any new polygons to the mesh. So it uses the information stored in the normal map to simulate how light bounces off of dips and valleys and ridges in a texture. So we're going to click this fix now to create a normal map. Now if we look at our level, we can see that there's definitely some depth. If we want to adjust that, we can use this normal map parameter here. So let's drop it down to maybe 0.5. Yeah, that's a little bit more subtle. I think that looks good. So let's save our scene. And if we hop into play mode, yep, we can see our level. So now let's add some interactivity. So the next thing we need to do is import our characters. So we're going to right click, import package, and characters. Give Unity a second here. So we are going to collapse a few of these. So we don't need the physics materials. So we don't need the roller ball or the third-person character. We want to make sure we save the cross-platform input and the utility functions. And then we're most definitely interested in the first-person character. So we'll click Import. And we should be good to go. So we're going to drill down into Standard Assets, Characters, Prefabs, and FPS Controller. Bring this out of the ground, just so it's a little barely hovering. We're going to rotate it 90 degrees, actually negative 90 degrees, the x-axis, or y-axis, I'm sorry. I'm just going to bring it back to maybe that point in the level. Save it. Let's hit play. And with that, we're walking around in our game. If I turn on my sound, I should have some footsteps. Yep. So one of the advantages of using the built-in FPS controller is that you can have something that's well-tested, well-written, well-documented, up and ready to go. You don't have to start from scratch. So we will see that we're getting this informational message about there's 2 audio listeners in the scene. If we open up the first-person controller, we'll see that there's a camera on the first-person controller. We also have a main camera here, and there's audio listeners on both. So we're not using this main camera anymore since we're using the first-person camera, so we'll delete this. And that error will go away. So the next thing we want to import is our object that we'll be interacting with in this level, and that's a switch. So in my models folder, I'm going to drag in a file called switch.fbx. So a couple things to note when you're importing a model. One of the most important things to keep in mind is the scale factor. So say you're importing something and it's way too big. One way of fixing that is having your 3D modeler go in and adjust the scale and export options on their end. In some cases that might not be an option. Maybe you're working with someone from overseas, or you bought a model from a marketplace and you can't have the creator just adjust it on the fly. So they have this slider here called scale factor, and you can use that to adjust the scale when you're importing the model. Then anything you do with the model from there will be multiplied by this scale factor. So if it's too big, you can drop it down. If it's too small, you can bring it back up. On this animations tab, we'll notice that we have an animation clip. And right now this only has one animation. If there were multiple animations, they would have start and end frames here listed. So maybe walk would be frames 0 through 60, run would be 60 through 120, things like that. Occasionally those won't get imported correctly, so you'll have to add them in here manually. If you're working with a 3D modeler, a lot of times they'll give you a reference sheet that will have the frame numbers, and you can simply add them in here with their appropriate names, and you'll be ready to go. But if you want to preview an animation, we can click this button here, and we can see in this model that I set up that it's making a basic switch animation. So the first thing we are going to do, let's go back to models, go to our switch, and drag it onto the scene. We'll notice that this has a couple of different objects under this switch object. So I'm actually going to create a new material just to make this stand out a little bit more. So new material, switch matte, and switch the albedo to maybe a tealish, greenish color. You can pick whatever color you think would stand out. Come over here, drag my material onto the switch. I think that looks good. So a couple more things to set up to make this switch interactable. To be able to interact with anything, right now we just have a game object with an animator on it. But to be able to interact with it, we're going to need to have something to detect different types of input. So we're going to go to Component, Physics, Box Collider. Now if you notice, the collider isn't quite on the switch, and you would basically need to click around the switch to be able to trigger that. So we have these sliders we're able to move, and I'm going to center it roughly on our object here, narrow it down a tad, bring out the Y, and then definitely bring out the X, shape it up, let's fly around. Yep, we're a little bit off. It's always good to check things from multiple angles. A little bit more on the, oops, a little bit more height on the Y. Basically just fool around until it looks good from all angles. And it doesn't hurt if it's a little bit too big. A lot of times it's actually helpful if it's a little bit too big. Alright, that looks good. So now we have something we can interact with our switch. The next thing we need to do is create an animation controller to be able to control our switch. So let's actually just create this in the models animation controller. We'll call this switch anim controller. Now if we double click this, it'll open up a new view that we haven't seen before called the animator. We'll want to go to our switch on the scene and drag our animation controller to the controller parameter. Now the next thing we want to do is grab our switch object and actually drag it in the animation controller. And this will set us up with this animation here. So we're going to create a new state. And basically with this we're kind of visually scripting how things will work. It seems a little bit counterintuitive, but once you get the hang of it, it makes a lot of sense. So basically our switch will be able to be in two states, either on or off. So I'm going to name this state switch on. That's basically going to represent if the switch is on. And we want this to be the default state. So I'm going to set this as the layer default state. And over here we have this parameters. And we also want a Boolean. So I'm going to click the plus here, add a Boolean, and name it the same thing. Switch on. I'm going to set that Boolean to true. Looks like that didn't take. There we go. So that means we have a Boolean, the switch is on, and the state when we start our game will be the switch is on. when this Boolean is set to false, we want to switch to switch off. And how do we make that happen? So the first thing is we want to transition. So I'm going to right click, make transition. So now we have a way to get from switch on to switch off. But we need to tell Unity when that needs to happen. So I'm going to click this transition here, and we can add a condition. And all we need to do, click here, and when switch on goes to false. So when that happens, we're going to move from the switch on state to the switch off state. So the last part of hooking this up will be setting up the necessary scripts. So in our scripts folder, I'm going to add a new C# script. I'm going to call that switch and open it up. And this will be a fairly short, simple script. So the first thing we want to add is a private animator anim. We're also going to need a private audio source sound. We haven't used this yet, but we'll use it in just a moment. So in here we need to set our animator. So anim equals get, capital get component animator. And the same with our audio source, sound equals get component audio source. And we'll pause here with this script. The other script we need is our game manager script. And since this is a little bit more of a complex script, it's actually included in the project files I've provided. I'm just going to add it real quickly. Alright, fix the formatting here. Make sure these all line up. Alright, so let's walk through this script. Basically, we want to know whenever the user clicks on one of our switches. So the first thing we're going to do is in our update function, figure out when the mouse button is clicked. So we'll use input.getButton, fire1. The next thing we want to do is array cast. And if you think back to algebra, array is just a straight line. And it's the same thing in Unity. One way to think about array is just kind of like a laser just being shot forward. And the way we can use it is when it hits something or interacts with something or pierces something, we can figure out what object was hit. So that's what we're doing here. We're creating this raycast. We're going to use camera.main.screenPointToRay. And this basically uses the center of our camera as the point that we spawn our ray from. We have this raycast hit object where the raycast objects that were hit are returned. Then we want to say if physics.raycast ray, and this is the ray we created, if this is basically hitting something, return this object. Then what's nice is we can also use this object and get some information about what was hit. So we have this line here that says hit.transform.tag equals switch. So if we hop back here, we want to make sure we take our switch and create a new tag called switch. And then adding that to our switch object. Then we're going to AND. So two conditionals in this statement. The first one is making sure the object we hit was a switch. This next one is getting the component, the animator component. So the same animator that we just worked on. And we're going to get the bool switch on. So if we go back to our animator, we're trying to see if this is enabled or not. Because basically we want to make sure if our switch is off, we don't want to try and turn it off again. We're getting the audio component. Actually, this line isn't needed. There's a debug statement that says the switch was touched. We're getting our audio, we're getting our animator component again, is setting switch on to false. We're getting our animator component and setting that bool switch on to false. So that means our switch will be off since switch on is false. And when this is false, we should fall into the switch off step. So now the last thing to do is to make sure this is saved. Go into our scripts, drag the game manager to our FPS controller, and let's give it a test. And we touched our switch, the debug statement fired, and our switch got switched off. Awesome. So next thing we're going to do, if you picked up on it, is add in some audio. So I'm going to add another folder called audio and drag in our audio clip. Then the next thing to do is just drag that onto our switch. Now we have a audio source. We want to make sure it plays on awake, and then we want to make sure it loops. Then the other important thing is in the spatial blend, we want to move this from 2D to 3D. If we left it on 2D, it would basically play the same volume no matter how we walked around in the level. If we move it to 3D, if we get away from where it is, or we walk further away from it, or something like a wall or a box is in between us, it's going to be softer and eventually fade out so we don't hear it. And then at the Doppler level, we're just going to bump this down slightly. So let's say 0.7. We'll start out with that. Now if we hit play, we'll see this alarm is going. Now what we want to happen is when we turn our switch off, that alarm stops. So let's hop back into our scripts. And switch. So we already have that Boolean called switch on, and we can basically reuse that. Since the animator is already on our switch, we can get access to that very easily. So add an if statement here. If anim dot get bool switch on equals false. We want our sound, which we're already getting a reference to because we already set that up, dot stop. Want to make sure we add it to our switch. So we have the audio source, the script. Let's hop back in. And it turns off. We see the switch go off and the sound stops. So now that we have this completed switch, you probably guessed it, but we're going to take this switch, drag it to prefabs, and now we have this nice switch prefab. So basically, to finish up this short project, there's two things that need to be done. So one, you can scatter these switches all around the level. Maybe you want to place some cubes, make obstacles out of the cubes. Maybe we can take a switch and do something where, let's hold control. We'll put the switch on the side of here. Maybe there's some cylinders, just kind of create a maze. And basically you'll need to use sound to find out where these switches are placed. So now that we have multiple switches, they each have their own sound. As we turn them off, we can turn and figure out where they're located. So the last part is when all the switches are off, we want to make sure that the game is completed, that we display some sort of victory or you win text on the screen. And there's some hints in the code along with the comments that explain how to accomplish that. But this will wrap up the last part of the coding for this semester. And at this point, you should probably give yourself a round of applause. Unity is a straightforward engine, but it's definitely not simple. There's a lot of power here, and being able to pick it up and learn Unity is a feat in itself. So this is a skill that you'll be able to take with you. There's a number of studios using Unity to create awesome games, and that list is only growing. So knowing the basics and some of the internals of Unity, how things work, how things are set up, is an awesome skill set to add to your belt. As always, if there's any questions, even after the class, always feel free to ping me, and good luck with your final.